I think we'll get started with wrapping up, and if some of you need to filter out for whatever reason, feel free. We would just like an exit ticket, so over the next 15 minutes or so, or before you leave, could you please give us, one bit of feedback, something you gained tonight, you learned tonight, a burning question you still have. What would you like us to know as a result of our conversations together? Mrs. Slattery brought the posters of the standards of mathematical practice, and I think that that really gets at the crux of why we are all here tonight and what we call this new math. Hopefully we see that these standards of mathematical practice, which are just a small part of the Common Core math standards, so there are 10 practice standards. When I first saw them, I thought, wow, this could be something that would apply in any setting, on a sports team, in a workplace, in a family. Would you want someone to make sense of the problem and persevere in solving it? Yes, at home. That would be something I would want to do if I'm tackling a project or I have a problem at home or whatever it might be. So at the end here, while you're filling out your exit slip, and you can just leave them on a bookshelf, maybe over here by the Be Respectful sign on your way out. What questions do you have? What's something new that you learned? What are you taking home tonight? What would you like to share with us, or what question would you like answered?
When did this sort of new math revolution begin? Because a lot of us have no concept that it was a new product. I do remember back in the day showing your work, and now you get credit for your work. And so did that always sort of been a new math, or is that
Yeah, that's a good question. So, when did this new math come about, and especially compared to how we learned math and were expected to show our thinking in math? The Common Core standards were first written, I believe, in 2007, adopted by a lot of states in 2009. We were part of the curriculum pilot in Middleton, again, because we noticed that kids in high school, there was just a disconnect between their level of understanding and the grades that they were getting. So in other words, they might know something for an exam. After they took the exam, I don't need that information anymore, and they might dump it. So in our district, we want to make sure that our curriculum is aligned to the standards that our state and district have adopted. And Common Core is adopted at the state level. They're federal standards that states sign on for or choose not to sign on for. Wisconsin is a Common Core standard state. So these 10 standards of mathematical practice, they are practice standards. They're not content standards. So there are content standards. And the way that those standards were written is we took a look at where do we want students to be in the end? We want them to be college and career ready. Well, what kind of math do they need to know at that point? And then the writers of the Common Core just scaled it back all the way to kindergarten and even pre-K, I believe. So the standards of mathematical practice are the kind of the doing. What do we want them to be able to do? What do we want to see when students are solving problems? So to answer your question, we started our curriculum renewal process when George moved into DAC from Elm Lawn. He really started putting each content area, social studies, art, math, on a rotating schedule. Every 5 years we would take a look at our curriculum. And so math was up, must have been 2008, 2009. We started looking at comparable districts across the state in demographics and also in achievement. And we wanted to know what the districts that were knocking it out of the park, what they had in common. And when we did that, we went and looked at some schools and we looked at what they were doing. And it was really the high school teachers that started all of this. I was in the middle school at the time. They just noticed that disconnect, like I described before, that kids could get good grades, but they didn't really feel like they understood it. And what we found was we needed students to understand the concept, and So where we're at right now is putting these standards into place, but I feel like we had already landed there ahead of time because we just noticed that disconnect and we wanted students to really understand.
So they're learning the same amount of content that they were before, but they're also now learning different ways of, different strategies, different ways of getting to that content. And I'm assuming that it just takes longer to grasp more different ways to do things. How do you accommodate for that additional time within the curriculum?
So the question was, how do we accommodate for the additional time in the curriculum that it would take for students to learn multiple strategies for solving problems? An example would be in 6th grade. One of my favorite lessons in 6th grade was where students learn where pi comes from. And the way that we do that is teams of students are blowing bubbles. The bubbles are landing on the table, and they take a piece of string and they measure the circumference, and then they measure the diameter, and they compare that to a ruler. So we get a measurement in centimeters. And then we make a T-chart, and you have your diameter and your circumference sitting across from each other. And lessons leading into that, we were talking about constant multipliers. Well, what is the constant multiplier between the diameter to the circumference for all of the different bubbles that you measured? And so, I kind of play with them a little bit. We scratch our head, what is the constant multiplier? And then the teams will talk, and then they'll say, well, it's 3. And then other teams will say it's 4. And then we say, well, it's not quite 4, and it's more than 3, and it's 3.14 is the constant multiplier between the diameter to get to the circumference. So they just learned how to do pi. They learned where pi came from by blowing bubbles on a table and measuring them and looking for that constant multiplier. So that strategy is going to stick with kids. When we could give them a note card or say, you can put all the notes you want for your test on this note card, and they might write the formula for circumference, but we want them to know it without having the little cheat sheet on the test. So that lesson, took a day for them to learn the formula for pi. So, it's just ingrained, and students are going to have more sophisticated strategies than their classmates might, but we need to give them, the video with Mrs. Scudder was a classic example of giving kids the voice where they can share their problem-solving strategy, and they're going to see different strategies, and they'll latch on to one that really makes sense to them. Did that answer your question?
A little bit, yeah. Having trouble seeing it in the big picture.
Yeah.
But.
And a lot of this curriculum, if you've ever heard of curriculum spiraling, it's introduced at a certain grade level or time, and then it'll pop up again, and they should have a deeper understanding of it then, and then it'll pop up again, and we really want them to know it at this time. So a lot of these math concepts spiral throughout these early grades.
It seems like there's a significant support component from home, from parents or guardians, in terms of using this curriculum. Can you reflect on what about students who don't have that kind of support? Do they do well in this type of curriculum? How do they fare with that?
So struggling students, what is our plan for them?
Yeah.
Mrs. Scudder, do you want to comment on that one? That's your department.
Sure. You're right, it does take help from home. And so the things that we have in place are me, for one. So I would work with any kid in any grade level, the most struggling kid. In K through 2, I work with the program called Math Advantage, which is a little bit more of the stuff that I gave you, like the 5 things, 10 things, those kind of things, common core, all those really basic skills. As they get older, so grades 3 and 4, I would do something called Math Navigator, which is it's a different program. So they'll still be in their regular math class, and then during IE time they would come to me, and we would work on sort of some of the skills they've missed. The extended school day is another thing that we have in place to help kids with especially getting homework done, and then doing some of my types of activities on the days that I'm able to be there, to help, kind of catch them up even a little bit more, hopefully.
Okay.
So something we have coming over the next 2 weeks are assessment meetings. Students have been taking assessments in reading and math, and we're going to look at what that data are going to tell us about kids. So we might find that based on our assessments that we've given, that we have a group of students that aren't so clear on a particular topic in math, and we make a plan for those students. It might be additional instruction. When Mrs. Scudder said IE time, that's called intervention and extension time. So we extend their learning from the classroom into a 30-minute period that we have every day. Some students will need to see an interventionist. Some students will have already learned the material and they need an extension activity, and some students need an intervention with their classroom teacher.
And this is done at every grade level?
Every grade level. 3 times a year we give assessments and we're checking for student learning. Why don't we go over here? Yep.
So it was kind of a discussion that we were having that came up. I mean, when we were growing up, it was, the flashcards, so the memorization. Is there any component, I think this is wonderful from the standpoint of really being able to understand, thinking through how you solve your problem. I think it carries over in many other areas as you've expressed. Is there any other element of memorization that goes along with this when they get up into the multiplication and different things like that, or is it all about going through some of these lattice and things to bring these numbers together?
So do we still need to know our times table?
Yeah.
Of course. If you're solving higher level problems and you don't have that down, that, what's it called, the
Automaticity.
automaticity, if you don't have that down, it's going to slow you down and it'll keep you from learning more difficult concepts. So,
Okay, so with
of
an
course, you
updated
need to
part.
know your times tables. Especially if students can make sense of the patterns within the times tables and really have a deep understanding of that. Some students, you can give them flashcards and they'll memorize it, where other students, that doesn't work so well with them. So they need to learn those concepts and see the patterns differently than other students might. But you have to have that automaticity.
Okay.
What about kids who aren't really struggling and maybe might have trouble staying engaged with the material? What sort of tools do you have for them?
So the kids they understand the concept, they're able to do their homework, the regular curriculum is working really well for them. What do we do for them? We would want to extend their learning. So students, when we do assessment meetings, we identify some students that need perhaps another math track. And in math is one of the content areas where we have tracks. So some students that are 4th graders are actually taking 5th grade math. We also have students that are kind of on the bubble. They're not quite ready to skip a whole year of math and to be accelerated in an accelerated track, but they need their learning extended. So we have someone like Ms. Bowles, who's our accelerated learning specialist, who's talking with teachers, identifying those students, especially during assessment meeting times right after we've given all of our assessments. And we have a plan for those students walking out of our assessment meetings during their intervention and extension time to extend their learning further. That's a question we always have to ask. What if the kids already know it? What are we going to do for the kids that already know the concept? We have to be prepared to extend their learning.
Can I ask a little bit more about that? Talking about this at kind of the same, what does that look like in something like kindergarten or 1st grade when when the teachers are completely just getting to know them, they're brand new to the school, that type of thing? What does extension and intervention, what does that look like really early on?
Early on, it looks like students pulling out their mats and they might be reading quietly during intervention and extension time. It also might look like the teacher pulling a group of students to a back table and doing an activity with them while other students are doing independent activities.
Also, when you saw the videos, it kind of depended which age group you were in. When they solve problems, there's going to be that opportunity for those kids to really watch the rest of the class with the ways that they're solving problems. And I'm guessing that the teachers could also give them, just you to go try this one and just write, because teachers will do that with the kids who are struggling. They'll, cross out the numbers in the book and put in lower numbers if they need to. There's no reason they wouldn't do it for the higher kids too.
And one of the benefits of having a workshop-style classroom, a workshop in a everyday sense might be we're in a woodworking shop and you're building a table and I'm building a bookshelf and you're building a coat rack. Well, we're all at different stages of building our project, but we all need to know how to use the drill press. So the teacher's going to bring us around the drill press and show us how to use the drill press so that we can all use it in our projects. That's what we use with Readers and Writers Workshop in our reading and writing classes, which our next community night will be on literacy. So you can find out all about that. But some of our math classrooms are moving more towards workshop approach. The teacher shows them a mini lesson and then the students are going off and working at their level. And just the questions that teachers are asking individual students is differentiating their learning. You can push students' thinking by the questions that you ask them. So at this time, it looks like we're all square. It's 8 o'clock. Please, if you could, leave us a note. We have some note cards at this table over here and some pens. If you could just leave us a nugget that you learned tonight or a question, a burning question that you still have, or just some feedback for us, that would be great. We'll see you bright and early tomorrow at Go Nuts for Donuts.